Thank you, Mike, for the introduction, and thank you to the organizing committee for putting together this panel and actually giving us this opportunity to present our research to all of you. And also, thank you to everyone here for choosing this session over the wine tasting that's going on right now. I'm sure that was not an easy decision. My name is Maddie, and I will tell you a little bit about what we do in our lab on the study of volatile sulfur compounds in winemaking. Volatile sulfur compounds, or VSCs, are a family of small aroma molecules that contain sulfur in one way or another. They're produced by yeast during fermentation, and we know this because we can't find any trace of them in the original grape juice with which wine is made. We see them increase in fermentation, and then it stays there. Some of them are also accumulated during aging and bottling. Most of them are off flavors, most of them, but not all of them. I'm sure a lot of people here are familiar with thiols. Well, those are not the ones I'll be talking about today. Now, I'll be talking about the nasty ones, the really bad-smelling ones, the ones you really don't want in your wine. And the reason we find these compounds so interesting is because, one, they have a very low sensory threshold. So even a small amount of them produced are enough to render a wine completely undrinkable. And two, there doesn't seem to be a lot of knowledge in how they're made. We know that yeast make them, but the pathway to how they're made and the enzymes that make them are unknown. We do, however, know quite a lot about one of them, hydrogen sulfide, the smallest of the VSCs. We know quite a lot because it's a metabolite naturally produced by yeast in the making of amino acids and proteins and essentially for growth. And as far as aroma compounds, this is pretty much as bad as you can get. It has a very strong smell of rotten eggs, and if, I don't know if you're familiar with geothermal parks in Rotorua, that's pretty much what it smells like. And winemakers that have been battling with this for years probably know that it accumulates during stock fermentations. Of course, it can be treated. You can add diammonium phosphate to continue growth of the yeast, and you can treat the wine with copper to remove hydrogen sulfide. But if you do this, you run the risk of also eliminating the good-smelling sulfur compounds. Moreover, a few years back, in a meeting much like this one, somebody made a very passing comment and said that if you leave hydrogen sulfide untreated, it tends to leave oniony off flavors in wine. And probably that person didn't know at the time, but this was a huge breakthrough for us, because chemically, something that smells like rotten eggs is very, very different from something that smells like onions. And what's more, they also said that these compounds, these onion-smelling compounds, you cannot remove them with copper. And that gives us a little bit of an insight into the chemistry of these molecules, because copper treatment only works with something that has an end sulfur, like the image on the left. It does not work with disulfides, and it certainly doesn't work with conjugated sulfur compounds. So with these two very important tips of information, a whole research project arose in which we tried to find out what these VSCs that arise with hydrogen sulfide are. Essentially, we wanted to find out how do you get from rotten aroma to cooked onions or veggies. And if we know what these compounds are and we know how they're made, can this process be stopped? So the first thing you always do in a research project is you do a big literature search. So we made a list of everything that we could detect for, every volatile we could detect for, and identified those that smell like onions or have been described to smell like onion or garlic. And as you can see, there's quite a lot of them. In fact, pretty much all of them smell like some form of rotten vegetable. So it could be one of these, could be two, could be all of them. So this wasn't a lot of help, but at least we knew what to look for. And because we knew what to look for, we could design an experiment. And our experiment is really simple. We just wanted to increase hydrogen sulfide production in wine and see what volatiles came out. To do this, we tried two different approaches. One, a more precise surgical approach, a biological. We just had the yeast make it, since it already makes it, have them accumulate it. And in the second approach, I guess a bit more brute force chemical approach, we just literally chucked hydrogen sulfide into the wine and saw what came out. So in the first set of experiments, I mentioned that hydrogen sulfide is already made by yeast naturally. And the way this works is yeast takes up sulfate from the media, it turns it into hydrogen sulfide at some point, and then this hydrogen sulfide in turn is turned into amino acids and proteins and growth. However, pretty neat trick. If you block this pathway just downstream of when hydrogen sulfide is produced, the yeast would still take up sulfate. It would still make hydrogen sulfide, but this hydrogen sulfide has nowhere to go, so it accumulates. And it is in this strain background that we found that 3 volatiles accumulate, and all 3 smell like onions. And that is ethane thiol, ethyl thioacetate, and diethyl disulfide. What's more, we saw that if you tag the sulfur atom in sulfate, and you trace it down the pathway, of course you make tagged hydrogen sulfide, but you also make tagged ethane thiol, diethyl thioacetate, and diethyl disulfide. So that's pretty cool. In the same setting, we also saw that the more sulfide you add, the more hydrogen sulfide you produce. And the more hydrogen sulfide you produce, the more of these three compounds you made. So this is a pretty cool direct link into how hydrogen sulfide can make these compounds. The other set of experiments we tried is the spiking of hydrogen sulfide into growing fermentations. And of course, we tried this with laboratory strains and synthetic grape juice because that's what we like to do. But we also tried it with commercial wine strains and commercial Sauvignon Blanc grape juices from 2 different years because we know that's what you like for us to do. And so we tried 6 different strains with 2 different juices from different years from the Rappaura region. And even though there were strain differences and there was juice variations, in every single instance, every single combination made the 3 same volatiles when you spiked it with hydrogen sulfide. In a second round of experiments, we did the exact same thing, except in this case, we split the original fermentation into 3. In one experiment, we kept the live yeast with the juice, as before. In another one, we killed the yeast with heat, but we left the yeast carcasses, I guess. And in another experiment, we removed the yeast altogether and just kept the juice. And then we spiked hydrogen sulfide into each one of these. Now, the reason we did this is because we wanted to find out if these compounds are made enzymatically or chemically. If they're made enzymatically, ideally, we would only find them in the green vial and not in the other 2. If they're made chemically, we would find them in all the vials. And what we saw is, first, well, there was basically no difference between the dead and no cell experiment, which is as expected. But we did see a pretty big difference for ethane thiol and ethyl thioacetate between the live cells and the dead cells. There is much, much more of these 2 volatiles made when the cells are alive, indicating our working hypothesis is that these are made enzymatically. In the case of diethyl disulfide, it was pretty much made in the same amount in all 3 conditions. So our current hypothesis on this one is that it's made chemically. So the conclusions and take-home message that I want to convey is that first, we were able to identify the onion-smelling aroma, so this rumor that came up that was produced with hydrogen sulfide. And these are ethane thiol, ethyl thioacetate, and diethyl disulfide. Because some of these compounds are made enzymatically, we believe there is a very strong possibility that in the future we could design a yeast strain that does not make them at all, probably saving a bunch of money. For now, however, the best alternative I recommend is to nip it at the bud and just try to not produce hydrogen sulfide, either by choosing strains that are low producers or being extra vigilant. And the reason for this is because ethyl thioacetate and diethyl disulfide cannot be removed with copper treatments. If you would like to know more about what I just presented, more details on the experiments, you can find it in this paper that we published earlier this year, or you can just simply contact me to my email address. And I wrote down, do you want to know more? We do too, because I can't stress enough how awesome it is that this whole project came out from a comment somebody made in a meeting much like this one in a social event. So what I'm trying to say basically is keep talking to us, I think we make a good team. And speaking of teams, I'd like to thank everyone who was involved in this project. Special shout out to Andy Frost, who I actually met today. He's been giving us juices for years, but I've never met him. And also to New Zealand wine growers and the Romeo Bragato Trust for funding to make this project available to you.
Great. Questions?
I do know of this link.
Can you just repeat?
Yeah, sorry. So is there a link between the thiols, the good-smelling thiols, and hydrogen sulfide, and if I'm aware of this link? Yes. I don't want to go too much into detail on this because there's a really good talk tomorrow by Leandro. I highly recommend you go to that one. But what I can say is that there's an issue of timing in it. So it's true that you do make thiols with hydrogen sulfide, but those are only made in the first 24 hours of the fermentation. These nasty smelling compounds are made much later, so there is a way to regulate that if you are careful.